Welcome, Chem students. My second attempt at a screencast. We're talking about periodic trends. The first trend we talked about today was the periodic trend of size. When it comes to size of atoms, the trend is that elements get bigger as you go down the table. So as you go down the table, things get bigger because we go from the first principal level to the second to the third to the fourth. So you can kind of picture there being an atom. There's the n equals 1, n equals 2, n equals 3, n equals 4. So as we are going outwards in these levels, that's represented by going downwards here on the table. The second trend is left to right. Over here on the left side, let's just look at an individual row. So if I just look at, let's just look at this row right here, the n equals 4 row. These elements over on the right have more protons in that level. More protons, like we talked about in class, actually squeezes those principal levels in just slightly, meaning that the elements over on the right side are going to be slightly smaller than the elements over on the left. The overall result is that the trend is that these are bigger as you go to the left. So for example, if I asked you 3 elements and I said, okay, I want you to rank chlorine, silicon, and strontium. Okay, so I got 3 elements here let's just say that we're ranking them from smallest to biggest. Well, what would you start with? Pause the video for a second, see what you think. Smallest is going to be the one that's farthest away from this corner. This corner here is the biggest corner on the table. Helium, smallest corner. Okay, following our trend that bigger is left and downwards. So the smallest one is going to be chlorine. It's closest to the top right. Second smallest is going to be silicon, and then lastly, strontium will be the biggest. Hopefully that makes sense. Let's scratch all this stuff. Let me give you 1 or 2 to practice on. So again, we're just talking about regular neutral atoms and the trend of size. So what if I gave you oxygen, barium, and carbon? Okay, so again, anytime I give you one, you can pause the video, try it, and then I'll show you how to do it. Oxygen, barium, and carbon, from smallest to largest, would be oxygen would be the smallest, then carbon, then barium. Okay, hopefully pretty straightforward. The second trend that we talked about, and this is the tricky one, is the one with the ions. So we talked about how to rank the size but of ions. Now when you do this, you need to do 2 things. Figure out what noble gas it becomes like, and use the number of protons if necessary. And what I mean by that is if they're tied, if they're the same noble gas configuration, if they have the same electrons as the same noble gas. So I'll just do an example, and then I'll give you one that you can try. If you want, you can pause and try this first one. So if I had you do an Sr plus 2, a Br minus, and a Cl minus. Okay, so strontium plus 2 is going to lose 2 electrons and end up being like krypton. I'm going to color code this for you. Bromine is going to gain 1 electron and also end up being 36 electrons just like krypton. And chlorine is going to gain 1 electron and be like argon. So hopefully it's pretty easy to see that because chlorine is only right here, not chlorine, excuse me, argon, 18 electrons, full 3rd level, that is going to be smaller than the others. So we can see that chlorine is going to be the smallest. And then in terms of the other 2, they're both like krypton. So both of them end up with 36 electrons in the 4th principal level. So we actually can't use our Prass trick of bigger is left and down to figure this one out. So our rule here is, kind of like we said on the last section, that more protons, if we're comparing elements on the same level, more protons equals smaller. Again, because sorry, that writing is illegible. It crunches the levels in. They're more attracted to the nucleus because more protons means more positive. So if you're looking at bromine and strontium, I want you to think for a second which one has more protons. So between bromine and strontium, they're both in the same level, because remember they both, when they ionize, end up with electrons only in the 4th level. Strontium always has 38 electrons, bromine only has 35. Because strontium has more protons is why it will be smaller. Not smaller than chlorine, but smaller than bromine. So bromine will end up the largest. And so if I wanted you to rank them from big to small, you would order them Br minus, Sr plus 2, and then Cl minus. One more quick practice. I'm just going to give it to you and show you the answer so you can check. Sorry, my stylus just kind of got a little bit messed up. Oh, there we go. So if I asked you to do, let's do calcium plus 2, potassium plus, and phosphorus minus 3. Okay, so pause, double check. If you look at it, they all end up being like argon. Calcium and potassium end up losing electrons, potassium ends up gaining, phosphorus ends up gaining, but they all end up with 18 electrons, which means we have to look at the protons. Calcium has the most protons, calcium ion will be the smallest. Phosphorus has the least protons, this one will end up being the biggest. Okay. Last but not least, we have the last two trends of ionization energy and electronegativity. We'll talk about this a little bit more in class tomorrow, but the big idea is that they are opposite. Ionization energy increases. When I say opposite, I mean opposite to the trend of size. Ionization energy increases, you go up the table and to the right, meaning that these elements over here, generally speaking, are harder to take an electron away from. Like we know, they want to actually gain electrons, most of them. Noble gases don't want to gain any, so it's really hard to take one away. Elements over here on this side, generally, they're okay with it. It's pretty easy. It takes a low amount of energy to take the electrons away. So if we're talking about ionization energy, sorry for the writing, my stylus actually broke there, so I'm doing this live and just doing it with my finger. Ionization energy, if I gave you yttrium, fluorine, and nitrogen, okay, so we got yttrium, fluorine, and nitrogen. Which one would have the highest ionization energy? Well, fluorine, most up and to the right, so fluorine would be the highest, and yttrium, which is the most down and to the left, this one would be the lowest. So if you were going to rank them, highest to lowest would be fluorine, nitrogen, yttrium. If it was lowest to highest, it would be yttrium, nitrogen, fluorine. Make sure you pay attention to what direction you are ranking things. Last but certainly not least is electronegativity. Electronegativity follows the same exact trend of increasing up and to the right. However, electronegativity is how much an atom wants electrons. And if you think about it, these elements on the right side, these noble gases, they don't want any electrons at all. Fluorine really wants electrons. So electronegativity increases as you go up and to the right, just like ionization energy, with the exception of noble gases. Those will always have the least. So if I gave you something like, calcium, neon, and nitrogen. Okay, let me get rid of the fluorine mark there. Calcium, neon, and nitrogen. And I asked you to rank them from low to high. Well, automatically, neon's a noble gas, and we recognize that even though it's up and to the right, neon is going to be the lowest. We recognize that the next lowest then is calcium, and then the highest is actually going to be nitrogen. So there's our ranking. Okay. So hopefully that helps. Just a little kind of overview of some of the stuff we did today. Make sure that you practice the THQ, I think it's 5-4, the one that's assigned tonight. And we'll be reviewing tomorrow for our test. Email me if you have any questions. As always, let me know if you have any feedback for the screencast and if there's any other topics you'd be interested in me giving you a little lesson on. Good luck, guys.